Hello and welcome. This is going to be a short video on using the quadratic formula. Now in class I actually went over the derivation of the quadratic formula. It's a whole lot of algebra. Surprise. But what is great about the quadratic formula is because we derived it using letters A, B, and C, what it means is it will provide us a solution, if there is a solution, for any numbers that we plug into it. And there are some circumstances where there actually is no solution, and the formula does a great job at telling us so. So first I'm going to write the quadratic formula down, and then we're just going to go at it and start applying it. So here we go. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Now that will give us the value for x that we are looking for. Notice the plus or minus in the formula means that there could be more than one solution, because one time we'd have to add what we get from the radical and one time we'd have to subtract when we get from the radical. And here's how we'll be able to tell how many solutions we get. If after we evaluate what's underneath the square root, if we have a positive number under there, well, the square root of that will still give us a positive number, and if you add or subtract a positive number, you're going to get two solutions, because adding one and subtracting one are doing different things. However, if what you get underneath the square root gives you a 0, well, the square root of 0 is 0, and you're only going to get one answer. Because if you add 0 or subtract 0, it's the same thing. You still have the exact same amount that you started with. So in fact, it is a double solution where you get the same answer twice. Either way you want to think about it. Although, if what you get underneath the square root is, and I just misspelled a negative. Did I misspell negative? Negative. I guess not. So if you square it in negative, then you will have no real solution. And we talked about how in the future we're going to develop a new set of numbers that is going to help us deal with new situations. Actually, they're just as imaginary as the numbers that we use today. It's just that they hold a different meaning and have a slightly different purpose that might work outside of our everyday, let's say, interaction with the world around us. So let's move on to actually using this formula to solve some problems. I actually want to start with number 2 because there's some big numbers here, and let's just get it going. So A, this would be 2, B, that would actually be a -5, and C, that would be 3. Remember that this comes from the general quadratic ax squared plus bx plus c, where all of these letters are either coefficients or c is actually a constant. So let's see, negative b. So negative would be +5 plus minus the square root of b squared, which would be 25, minus 4 times a, which is 2, times c, which is 3, all over 2a. Well, if a is already 2, then 2 a's would be 4. Now, I'm going to do some of this in my head, but I want you to know what I'm actually doing, so pay close attention. The first thing I'm going to do is I'm going to multiply all 3 of these together. 4 times 2 is 8, 8 times 3 is 24. So this right here, let's use another, I guess I minimized that. I did not want to minimize that. When I multiply those, I got 24. And here we go. If I do 25 minus 24, that will give me the square root of 1. And the square root of 1 is 1. So everything I just did led me to this point. I multiplied these out. I got 24. I did 25 minus 24, which gave me 1. The square root of 1 is also 1. And at this point, we know that we're going to have two answers. We need to do one where we use the plus sign, and we need to do another one where we use the minus sign. So this would be 6 over 4 which is 3 over 2 or 1.5, however you want to write it. And this would be 4 over 4, which is another way of saying 1. And there you go. We have our two solutions. We know that we should have had two solutions because we square rooted a positive number. Let's go back to number 1 right here. So A, B, C. Now, the first time I do this, I am actually going to go through it using the big numbers. However, I will show you a second way that might speed up the process for you if you're ready for it. So keep in mind you won't have to do it the second way if you don't want to. Negative b, again, is positive 5 plus minus the square root of 25. Short-term memory is a great thing. Minus 4 times a times c. All over 2a, which would be 10. Oops, I made a small mistake. Do you see it? It's about the 100. What's my small mistake? C was actually negative 100. Okay, whew. It would have caused us some issues. Now let's go through and do the same process again. I'm going to multiply all three of these, and since there is a negative times another negative, that will give us a positive. So this would be negative 20 times a negative 100 would give us 2,000. So if I have 25 plus 2,000, I would have the square root of 2,025. Now, that's probably not one that you have memorized. That's certainly not one I have memorized, but I remember doing this a week ago. So that would give me plus or minus 45. As I said, short-term memory is a beautiful thing. So now we're going to break it up into the positive and the negative using addition or subtraction. So you would have 50 over 10, because I added those, or I would have negative 40 over 10, because I subtracted those. This would give me an answer of 5, or this would give me an answer of minus 4. So there we go. We again got two answers because as we predicted by square rooting a positive, it's going to give us another positive number. And adding or subtracting a positive number is going to give us two different situations. Now, notice through doing this problem, we had to square root this huge number, and that might cause a few people to sort of freak out and shut down their overall problem-solving skills. There was actually a way from the get-go to reduce this problem to an equivalent smaller problem, and I want to show you how that kind of works. So first, let's erase all of this, and then we'll go at it again using the quadratic formula, and it might be a little bit more manageable. So keep in mind, what I'm about to show you, you don't ever have to do this. This is just another way to think about the problem. Well, earlier in a video, I talked about the idea of the GCF, the greatest common factor between all terms. And you can actually still factor out a GCF before you use the quadratic formula, and you will still get the same answers. The GCF in this problem would be 5. So imagine I had pre-factored out a quantity of 5. That is telling me that I would have k squared minus k minus 20. In other words, I have now a new a, a new b, and a new c. A is 1, b would be negative 1, c would be minus 20. And if you recall, our two answers from before were 5 and minus 4. Let's just write those up here. Okay, and let's see if we actually get the same two answers when we go through doing this. So looking at our problem, here it is, our formula, negative b plus or minus b squared minus 4ac. Negative b would be 1, plus or minus the square root of b squared, with negative 1 squared is still 1, minus 4 times a times c, negative 20, all over 2a's, which would be 2 times 1. Now it's time to simplify what's underneath our square root. Negative 4 times 1 is negative 4, times negative 20 would be 80. So if we do 1 plus 80, we get the square root of 81, which ends up giving us a 9. So 1 plus or minus 9 over 2. Well, that would be 10 over 2, or that would be negative 8 over 2, which again give us 5 or negative 4. And that is pretty amazing. Up here in the corner, here they are, 5 and negative 4. So if you feel comfortable with factoring out the GCF, if in some instances you want to reduce the problem, you still can, like we have in the past with factoring. If you just want to do plug and chug, which I get it, sometimes you just kind of want to turn your brain off and then just go through it, you know, that option is still available to you, but by pre-factoring it, you might prevent yourself an unnecessary headache with much larger numbers. As always, I hope this video was helpful to you, and happy mathing.